Hello students, in this video we are going to look at examples based on testing hypothesis one sample test. The first example goes like this. A manufacturer supplies rear axles for US Postal Service mail trucks. These axles must be able to withstand 80,000 pounds per square inch stress tests. So this is one of the specifications. But an excessively strong axle raises production costs significantly. Long experience indicates that the standard deviation of strength of these axles is 4,000 pounds per square inch. Long experience means this is a population standard deviation they have given us. The manufacturer selects a sample of 100 axles from the production, tests them, and finds that the mean stress capacity of the sample is 79,600 pounds per square inch. If the axle manufacturer uses a significance level alpha of 0.05 in testing, will the axles meet the stress requirements? So if the axles have to meet stress requirement, that means they have to be having a stress they can withstand 80,000 pounds per square inch. That is the requirements. So the information which is given to us is the mu is equal to 80,000. That is our hypothesis, that this particular population from which the sample is drawn is 80,000. So in short, our mu h0 is 80,000. The standard deviation they have given us is of the population, which is 4,000 pounds. Sample size is 100 pounds and the sample mean was found to be 79,600. So we are going to now first take two decisions. First, whether we are going to use Z test or T test, and second, whether it is one tail or two tail test. So always in the hypothesis testing, first we have to answer these two questions, right? So here, since population standard deviation is given, irrespective of sample size, we are going to be using Z test, which we have seen in my last video, and this is there is a table which clearly gives you the comparison, when to use Z test, when to use T test. So that table we are going to be using here. Let me just bring that table right now. So if you remember, this is the table which I am referring to. If population standard deviation is known, irrespective of the sample size, we are going to use Z distribution. If population standard deviation is not known and the sample size is less than 30, then we are going to use T distribution, right? So that is the only one place where we are going to use T distribution. Okay. Right. So let us come back to our example. So here we are going to use Z distribution because population standard deviation is known. Also, now if you read the explanation clearly, that obviously the requirement is 80,000, so less than that is obviously not acceptable. But this statement clearly mentions that if you increase it beyond 80,000, then the production cost increases significantly, and hence even on the higher side we are not going to accept it. So there are rejections on both sides. Hence we will have rejection areas on both sides, and hence it is a case of two-tailed Z test. On the lower side also we will reject, on higher side also we will reject. So now let us write the null hypothesis and alternate hypothesis. Null hypothesis H naught mu equal to 80,000 and alternate hypothesis mu not equal to 80,000. Why not equal to? Because higher also there is a rejection, lower also there is a rejection. And significance level alpha 0.05. So let us first calculate Z by calculation, ZC, and then ZT, the table value, and then try to see whether we have to accept the null hypothesis or not. So Z, the formula we all know, that x bar minus mu h naught upon sigma x bar, and sigma x bar is sigma upon root n. So sigma x bar is 4000 upon square root of 100. So you will get 400, and Z calculated will be x bar is 79,600 minus 80,000 divided by 400. So Z calculated is -1. Now we have 5% level of significance. That means the area on both tails is equal to 5%. So on one side it is 0.025 and other side is 0.025, right? And then the calculated value of Z table value of Z will be calculated from the Z table corresponding to 0.5 minus 0.5. So which will get the value 1.96, right? So you know how to do it, right? Because we want 0.025 here. So 0.5 minus 0.025, and then for that you are going to search that value and you will get Z table is 1.96. So our acceptance region is plus 1.96 and minus 1.96, and our calculated value is -1, which is clearly falling in our acceptance area. It is somewhere here. So our acceptance area is between these two, and it is our Z calculated is acceptance area, and hence we accept the null hypothesis. So we conclude that since the sample mean lies in the acceptance region, the manufacturer should accept the null hypothesis. And what is our null hypothesis? That the mu, that is the population strength, is 80,000 pounds per square inch, right? So that is how we accept the null hypothesis in this case. Based on the sample, the manufacturer should accept the production run as meeting the stress requirements at 5% significance level. Right, now let us look at another example, example 2. A hospital uses large quantities of packaged doses of a particular drug. The individual dose of this drug is 100 cc. The action of this drug is such that the body will harmlessly pass off excessive dosages. So this particular statement clearly says that even if it is more than 100, there is no problem because there is no effect on the patient. But on the other hand, insufficient dosages do not produce desired medical effect and they interfere with patient treatment. So clearly lower side we will not be able to accept the consignment. The hospital has purchased this drug from the same manufacturer for a number of years and knows that the population standard deviation is 2 cc. The hospital inspects 50 dosages of this drug at random and from a very large shipment and finds the mean of these dosages as 99.75. If the hospital sets a 0.1 significance level and asks us whether the dosages in this shipment are too small, how can we find the answer? So clearly the given information is given here. Hypothesized mean is 100, standard deviation of population is 2, sample size is 50, x bar is 99.75. Again we have to take these two decisions, two questions, Z test or T test, one tail or two tail. Now see, clearly population standard deviation is given, which qualifies it for Z test. Now, from the statement, it is clear that higher side there is no rejection, but only on the lower side there is rejection. Because if it is on the lower side, it is going to significantly affect the treatment, and hence the rejection is only on one side. So clearly, this is a case of one tail Z test with lower tail of rejection. So in such cases, we will have to write our alternate hypothesis as mu less than 100, right? So null hypothesis is mu equal to 100 and alternate hypothesis is mu less than 100 and alpha 0.1 level of significance. So now Z calculated and ZT is calculated here with these two formulae, and we got here the answer for Z calculated is minus 0.88, and from the table, the Z table, the 0.5 is the rejection area on the left side. So this is 0.4, and for 0.4 our Z is 1.28. So our rejection is this side minus 1.28 and lower is our rejection value, critical value for rejection. And on the right side of minus 1.28 is acceptance region. Our Z calculated is minus 0.88. So it clearly falls in acceptance region, and hence we will accept the null hypothesis that we can conclude that mu is 100 cc. So our conclusion is, on the basis of this sample of 50 doses, the hospital should conclude that the dosages in the shipment are sufficient and we should accept the consignment. So this is an example of one tail rejection. Now let us look at one more variation, example 3. Sales manager of a pharmaceutical company handling cardio divisions studying the impact of a new digital marketing technique on one of their most loyal cardiologists. To see the impact, he collected the data from retail pharmacy stores in nearby area of the doctor's clinic. The earlier average sales per week of this star drug used to be Dastor 10, the drug name, is 471 strips. And he believes that the digital marketing initiatives targeted at this cardiologist would increase the sales significantly above 471 strips per week. So he collected 10 weeks data, and this is the data. Use 5% level of significance to test his hypothesis with assumption that the sales are normally distributed in the population. So what he believes is that the sales has increased for more than 471. Right, now let us first look at the information. This is the data collected for 10 weeks, and if this is your x, your mean will be 501.2, and then for variance you will have to calculate x minus mean the whole square, which is here. Then you add these values and you calculate divided by n minus 1, that is 9, and you will get variance of 1476.178, and the square root of that is 38.42. So from the calculation we come to know that the mean of the sample is 501.2, standard deviation of the sample is 38.42, sample size is 10, hypothesized mean is 471, significance level is 5%. Again, we have to take two decisions, Z test or T test, and one tail or two tail. Since the population standard deviation is not available and the sample size is only 10, that is less than 30, we have to use T test. Now, since we need to establish whether the sales have significantly increased due to digital marketing technique, clearly it is higher side of one tail test, because our acceptance our rejection is on the right side. Hence, this is the case of right side one tail test, because we are going to establish that the sale has increased is on the right side. So we will follow the same process. Sigma x bar we will calculate, but here we are going to use uh, the sample standard deviation, as population standard deviation is not available. Sample standard deviation is our best estimate for population standard deviation. So use this and we'll get sigma x bar, the standard error, as 12.15. So T calculated. Now we are going to use T table here. So T calculated is x bar minus mu h naught upon sigma x bar, and you substitute and you will get 2.48. Degrees of freedom is 9, and if you use the table, T table, and we have seen how to use that, corresponding to 9 degrees of freedom and area under both tails as 0.1, because alpha is 0.1, we get T table as 1.833. So if you see the diagram, 1.833 is our critical value, and on the right side we reject the null hypothesis, rejection area. On the left side is acceptance area. Our value for T calculated is 2.48, which is clearly falling in the rejection area. Hence here we reject the null hypothesis, and the null hypothesis actually is not stated here. You have to state the null hypothesis, which is going to be your null hypothesis will be here. In this case it will be mu mu is equal to 471, and alternate hypothesis will be mu greater than 471. So in this case we accept the alternate hypothesis, and we conclude that the sale has significantly increased more than 471, in this case at 10% or 0.1 significance level. Thank you.